Hey friends, in this episode we'll see about the importance of boiler question answers. Know your boiler now. What is boiler? Boiler is a closed vessel in which the heat produced by combustion of fuel is transferred to feed water to generate steam. It's also called a heat exchanger. Boiler is a closed pressure vessel with capacity exceeding 22.75 liters used for generating steam under pressure. It includes all the mountings fitted to such vessels which remain wholly or partly under pressure when steam is shut off. That is, when the consumption also is shut off, the steam pressure remains constant. That is called a boiler. What are all the mountings in a boiler? What is meant by mountings? Fittings on a boiler which are required for its safe operation are called mountings. Boiler mountings are safety valve, water level side glass or gauge glass, pressure gauges, blowdown valve, main steam stop valve (MSS), feed check valve (NRV). Each will normally used in fire tube boiler, air vent valve, drum vent, startup vent, and manual. These are all the mountings which are must for boiler. It will come along with the erection. Accessories we can add later. What is known as accessories? What are boiler accessories? The devices which are used in a boiler as an integral part and help to run the boiler efficiently are called boiler accessories. Boiler accessories are superheater, desuperheater, economizer, aerator, soot blower, feed pump, induced draft fan and forced draft fans, air shimmel system for coal-fired boiler, fuel supply system, dosing system, deaerator. Deaerator normally used in all type of boiler to remove oxygen from boiler feed water. Dosing system also is used for the high pressure boiler. Fuel steam supply system is also there. Ashimol system will be used in coal fired boiler. Induced draft fan and forced draft fan, which is called balanced draft boilers. Both are used. Feed water pump normally used for all the boilers. Food blower will be used for liquid fire and coal fired boilers. Air preheater is used in all the boilers. Economizer is used when you require and for high pressure and steam which is used for turbine and super steam requirement. Superator and desuperator are added in the boiler. These are all the boiler accessories required are provided after the mountings. What is the difference between steam boilers and steam generator? A steam boiler consists of the containing vessel and convection heating surface only, whereas steam generator covers the whole unit encompassing water valve tube, superheater, aerator, and economizer. This is the difference between steam boiler and steam generator. Now we can see the difference between water tube boilers and fire tube boilers. Water tube boiler, feed water flows inside the tube, whereas in fire tube boiler, hot flue gas flows inside the tube. This water receives the heat from the hot flue gas which flows at its outer surface in water tube boiler. The tube is surrounded by the feed water in fire tube boiler. As the outer surface of the tube is exposed to the flue gas, the heating surface is more as compared to the fire tube boiler in water tube boiler, designing for same number of tubes. As flue gas flow inside the tube, only inner surface is exposed to the flue gas. So for the same number of tubes, the heating surface is less as compared to the water tube boiler in fire tube boiler. In water tube boiler, the rate of steam generation is more rapid because of the boiler tube is exposed to the flue gas surface more. Whereas the rate of steam generation is less rapid in fire tube boiler. The chances of explosion is more because at water tube boiler the surface exposed to the flue gas surface is more and temperature in the inside the furnace is also very high compared to fire tube boiler because the steam generation is less rapid and water in the shell and is exposed to flue gas is very less because inner surface only will expose come in contact with the flue gas, so damage of the shell will be, the source explosion will be reduced in a fire tube boiler. The risk of damage in this case is less in water tube boiler, whereas the risk of damage is very high in the fire tube boiler as the surface exposed with flue gas heat transfer is less. So most of the part in the shell flue gas will go and not flue gas go as such, and the temperature will go more in flue gas fire tube boiler compared to the water tube boiler. So the risk of damage is very high. Less force is required in water tube boiler, whereas more space is required. The cost and construction problem also is very less in water tube boiler, whereas cost and construction problem is very in fire tube boiler. Water tube boiler steam pressure can well go exceed 125 kilogram per centimeter square. We can go more than that also. Whereas fire tube boiler or medium pressure boiler, steam pressure is limited to 25 kg force centimeter square per centimeter square. Water treatment is required. Scaling will lead to tube bursting in water tube boiler because high purity water is required for high pressure boiler, so water treatment is must. Whereas water treatment is not necessary as minor scaling would not go far enough to cause overheating and tube bursting in fire tube boiler. You can use soft water also in this fire tube boiler because it is a medium type and low pressure type boilers. Not much skill is required for efficient operation in fire tube boiler, whereas more skill is required for efficient operation in water tube boiler. Transportation is comparatively easier in water tube boiler because only tubes and all the parts are easy to transport, whereas transportation is inconvenient due to very large size of the shell. And water tube boiler is suitable for all type of power plants, whereas fire tube boiler is unsuitable for power plants because pressure is limited. We can go up to 25 kg per centimeter square only. Fusible plug is not required in water tube boiler, whereas fusible plug is required in fire tube boiler because it is in radiation zone. So when the heat transfer is not proper or when the shell is not having any less water level in the boiler, then the fusible plug will melt and water will quench the fire. So it is required in fire tube boiler. Now we can see how boilers are classified. Boilers are classified depending upon the fuel used, pressure of steam, mode of flow of heat carrying substances, etc. Mostly boilers are classified as follows based on the heat source: fuel fired boilers, waste heat boiler, nuclear powered or electric powered boiler. Mode of circulation of feed water: natural circulation or forced circulation. Type of fuel is coal fired boiler, oil fired boiler, gas fired boiler, and bagasse fired boiler. Position and type of furnace: external fired or internal fired. Material of construction: based on the material of construction, it is classified as cast iron boiler and steel boiler. Based on shape and position of tubes: straight tube, bent tube, horizontal tube, vertical tube, and inclined boiler. Based on the content of the tube, this is a major classification: fire tube boiler and water tube boiler. Based on operating pressure of the boiler: low pressure boiler, high pressure boiler, subcritical boiler, and supercritical pressure boiler. Purpose of utilization: marine, ship, locomotive, for trains, power generation, and industrial boiler. What is subcritical boiler and supercritical boiler? In high pressure boiler, natural circulation of water is limited up to the critical pressure 221 atta. At critical pressure, the density difference of steam and water is zero. So the boiler is once through type. Boiler which is operated above critical pressure is called a supercritical boiler, and the one which is operated below critical pressure is called subcritical boiler. Subcritical boiler has economizer, evaporator, and superheater. Whereas in supercritical boiler, feed water from economizer is directly admitted to the furnace at one end, and superheated steam is collected from the other end of the tube. There is no drum inside the supercritical boiler. It is without a drum. Now we can see the different types of fuel used in boiler. Wood-fired boilers, coal-fired boiler, crushed coal fired in Travagate using a coal sputter. Coal sputter is used to throw the coal, and a machine called Travagate which is used to help the coal to fire in the bed, and it will discharge the ash to the belt conveyor or submerge the ash belt conveyor. Then pulverized coal is fired in suspension using the coal feeder in the coal fired boilers. Bagasse fired boilers. Bagasse are fired in suspension in this type of boilers. Oil fired boiler. High speed diesel HSD, light diesel oil LDO, heavy fuel oil HFO, low sulfur heavy stock LSHS, and furnace oil. These are the liquid fuel used in oil fired boilers. High pressure oil is atomized using air or steam in the burner for oil fired boilers. So it is atomized to get proper combustion in the furnace. Gas fired boilers, petroleum gas, coal gas, blast furnace gas, coke oven gas, natural gas are used in boilers. Waste heat boilers are waste heat boilers. Heat from the hot waste gases of chemical reaction is used in the waste heat boilers. Electrical power boilers. Electrical energy is used to generate steam in the electrical power boilers. Nuclear powered boilers. Here the controlled energy of thermonuclear fission reaction is used to generate steam. What is the advantages of supercritical boiler? Supercritical boiler generates steam at temperature and pressure above the critical point of the water. Supercritical is a thermodynamic expression describing the state of a substance where there is no clear distinction between the liquid and the gaseous phase. Water reaches this state at 1221 bar. This point is called as critical point. At this critical point, the liquid and gas phases of water coexist. Both will exist at 221 bar. There is no need to separate steam from the water in a drum. So for a given output, lower fuel consumption and thus lower carbon emission than other less efficient system is achieved in supercritical boiler. The load change rate capability of the steam is not restricted by the turbine. The load change also will not affect the turbine in the supercritical boiler. Steam temperature at the inlet and outlet of the reheater is nearly constant over a wide load range. Even with different load range, the temperature remains constant. The boiler feed water pump power is significantly reduced at lower loads in this supercritical boiler. It requires short startup times. At higher plant efficiency or the entire load range is attained in supercritical boiler. These are the advantages of the supercritical boiler. Now you can see the schematic diagram of the supercritical boiler. Critical point is 221 bar where the water and steam coexist. This is a feed water entry. This is a combustion chamber. Hot air, cold air is coming and hot air is going out. And this is the combustion chamber. Rapid evaporator, superheated steam. The feed water enters and goes out of the superheated steam. The feed water pump and exhaust gas goes out. This is the air preheater and this is called economizer because going to the conducting type and radiation type in the combustion chamber is the once through type. There is no steam drum or mud drum is in the critical boiler. So there is water and steam phase coexist. So water enters here coming out of as superheated steam in this type of supercritical boiler. Now we can see another important accessories of boiler. What is steam trap? A steam trap is a self-contained valve that automatically drains steam condensate and discharge air and non-condensable gases from a steam containing pipe or vessel. It opens the flow of condensate but prevents the flow of steam. This is called a steam trap. It is used in all type of steam handle system. What is the purpose of steam traps? To allow condensate to exist as steam system while preventing the passage of steam until it has given up its heat by condensing back to water. Trap protect equipment and operators from the process problems of condensate backup in exchanges, vessel, and piping system. The trap is used to protect the plant from water hammer, turbine erosion, and machinery failure. If the water particles carried out or condensate is coming with the steam, the line will get out water hammering, and if the water particle is coming to the turbine, blade will get affected or turbine will trip, and machinery failure also will occur. Steam trap is used to improve heat transfer in the heat exchangers where the steam is condensing. Steam condensation is more means trap is used to remove the condensation. It is used to reduce the plant operating costs by more effective use of steam energy. You can reuse the condensate back, and steam is pressure is just used in reducing session, medium pressure to low pressure to very low pressure, and condensate is removed, and the steam is used for further usage in this type of requirement. For this use of traps, what are the important performance requirements of steam trap? Steam trap, it will vent air and non-condensable gases from lines and equipment for fast startup. So after the initial startup or in between startup, when lining up steam from the boiler to the consumers, you have to remove air from the line and condensate from the line, so to avoid water hammering and thermal expansion. So it will vent air and non-condensable gases from the line. Through the trap bypass, we can remove all these vent air and condensable gases, and also we can remove the condensate until we get free and dry steam. Then we can line up the trap. So it is help to line up the steam, and it will help the startup very fast. Remove condensate that forms and collect for proper operation and equipment protection. The steam trap is used to collect condensate and is used for proper process operation and equipment protection. To respond to changes in pressure, the boiler pressure changes also, and temperature also will change accordingly. And due to load change also, trap will be useful for effective condensate removal. It conserves steam that thereby save the energy. So energy is saved when trap is used properly. What are the main types of traps? There are three main types used in process, drip, or tracer and tracer application: thermodynamic trap, mechanical trap, thermostatic trap. Hope you have understand some important questions in the boiler. You might have known the boiler question answer discussed here. Different classification, type of fire, boiler, fuel used in the boilers, and the main usage of advantage and working principles of advantage of trap, and the main classification of trap. We will see about the trap in the next episode. Do not forget to subscribe and share with your colleagues and friends. Thank you very much for putting your like and comment in the comment box. See you in the next episode.